This video is about finding the area of parallelograms. Alright, so first let's just remember what area is. The area of a figure is the number of square units needed to cover a surface. Alright, so perimeter, if you've done perimeter before, that would be the distance around something, like a fence around the yard. Area would be the number of square units it takes to cover like a floor or tiles, like square tiles in a bathroom or something like that. That's a measure of area. All right, so a parallelogram is what we're finding the area of today. It's a quadrilateral, meaning it has four sides whose opposite sides are parallel. So that applies to a lot of different shapes. It includes the rectangles, the squares, rhombuses. They're all parallelograms, and then just regular parallelograms as well. So they all use the same formula. And in elementary school, you may have been taught that the area of a rectangle is length times width. And that's still true, but that only applies really to rectangles. So we're going to broaden the area formula and make it include all parallelograms. So it looks a little different maybe than what you learned before. It's still the same basic idea. The area of a parallelogram is the product, meaning you multiply, of any base and its height. All right, so with a with a rectangle, you just called this a length and a width. But in a parallelogram, because the rectangle is slanted a little bit, the base is this bottom part here, and the height is this part going up and down. Now, one thing you want to look for in a parallelogram is that the base and the height have to form a right angle. So that's different than the side right here. So if they give you this information here, that's not really useful in finding the area. What you want to know is this part right here, because this is the piece that's making the right angle, right? So that base and height have to form a right angle, and remember that little symbol right there, that little box is telling you that's a right angle. And the formula you're going to see looks like this. A equals BH, which means area equals base times height. All right, so if we apply that to these problems, I'm going to erase this a little bit. Okay. It says determine the area of a parallelogram. So the first thing we always want to write down when we're talking about area is the formula that we're going to be using. Up until this point, maybe you haven't used several different types of formulas, but as we go through this geometry, you know, there are going to be a lot of different formulas. And so all formulas pretty much work the same. You plug in the information you know, and then you solve it. And you just have to make sure you pick the right formula. So that's why we encourage you to write it down each time. Since this is a parallelogram, the formula I'm using is base times height. Now remember, when you take your STAR test in the spring, you'll be given some information on a resource sheet. It has a list of several formulas. This is, again, the formula you're going to see on that sheet. So they're not going to tell you length times width for a rectangle. They're going to give you a formula that says the area of a parallelogram is base times height. So again, you want to be familiar with the way this looks. All right, so all we're going to do is replace B with whatever the base is. So remember, the base is this piece down here. So if we're looking at a picture in the grid right here, we first need to count this bottom, the number of squares. So we want to go from here to here, that's 1. From here to here is 2. Here is 3, and here is 4. So the base is 4 units. The height is how tall the parallelogram is. So you can see the right angle here. That's important to look for. So we're going to count the number of squares it takes to get to the top here. This would be 1, 2, 3, 4, 5, 6, 7. So the height is 7. So now that we know the base and the height, we can plug that into our formula. We're going to replace B with 4 and H with 7. And in our formula, that means we're going to be multiplying 4 times 7. Well, 4 times 7 is just 28. The area is 28 square units. You can write it this way, or you can write it with an exponent of 2, because that also means squares are squared. So this is 28 units squared, or square units. In example 2, we're determining the height of the parallelogram. So we're still using the formula for a parallelogram. A is equal to base times height. But this time we're not solving for area. So if you look at the picture, this can be a little tricky when you first look at it. This down here, it looks like where they normally tell us the information for the base, but it's not B equals, it's A equals, which is the area. Notice the measurement is in square units. That's another clue that this is area. So the base actually is this number right here, the 6 inches. So what's missing is how tall our parallelogram is, which is the height. Okay. So what we want to do is use the same formula to solve for height. So now we're going to replace different parts of the formula and then solve for what's remaining. So if I replace A with 24, now I have 24 equals, the base we just said was 6. This is the base right here. So 6 times the height. And then we have an equation that we need to solve. So if you think back to our last chapter, remember we're going to cut this in half. And then we're going to use inverse operations in order to solve it. So we can't multiply times 6. We're going to do the opposite, which is divide by 6. All right, so these cancel out. 24 divided by 6 is 4. This is equal to the height. So the height is actually equal to 4 inches. Because it's a measurement of distance from here to here. And it's not an area. The height is just in regular inches, not in inches squared. So let's keep going. It says to determine the area of each parallelogram. So notice this here is a square, but we're still going to use the same formula because it applies to all parallelograms, which includes the square. So we need to do base times height. This time base and height are the same, so we're going to be multiplying 2/3 times 2/3. These are fractions, so remember how to do that. Multiplying fractions ain't no problem. Top times the top, bottom times the bottom. So 2 times 2 is 4, 3 times 3 is 9. So my answer, I can't simplify that. It's going to be 4/9, and this is going to be in square miles or miles squared. And the second problem, again, this is a parallelogram, so my formula is going to be base times height. The base this time is 18. Okay, notice they're talking about this part right here. So the B is going to be replaced with 18. And then the height, notice they had to draw the right angle out here, but that's still how tall the parallelogram is. It doesn't matter that it was outside of the parallelogram. So we're still going to use that as the height, so that's 35. And all we have to do is multiply it. So 18 times 35. 5 times 8 is 40, carry your 4. 5 times 1 is 5, plus 4 is 9. Start with a 0. 8 times 3 is 24, carry your 2. 3 times 1 is 3, plus 2 is 5. And add them up. 0, 4 plus 9 is 13, 630. So our area here is going to be 630, and this is in square centimeters. There. All right, the third example right here is also a parallelogram, so I'm using the same basic formula, base times height. This time the base is 8.8, and the height, you can see it making the right angle, is 10.4. All right, so now I just have to remember how to multiply by decimals. It doesn't matter which one you put first, so I'm going to put the one with the most digits on top. 4 times 8 is 32, carry my 3. 8 times 0 is 0, plus 3. 8 times 1 is 8. Start with the 0. 8 times 4 is 32, carry the 3. 8 times 0 is 0, plus 3, and 8 times 1. Add these up to 5, 11, and 9. I have 2 decimal places here, so I need 2 here. So my answer ends up being, area is going to equal 91.52. And this is going to be in square meters or meters squared. And number 4, it's asking us to determine the height of a parallelogram if its base is 9 feet and the area is 27 square feet. So it's a parallelogram. I know I'm going to be using the formula A equals base times height. But notice the information they're giving us. They're wanting us to, first of all, we're finding the height. We're finding H. All right, so the base is 9, B is going to equal 9, and area here, A is going to equal 27. So you make sure you're plugging in the right numbers in the right place inside the formula. So I'm going to replace A with 27, that's over here. The base is 9, that's going to go here. And then H is what I'm going to look for. All right, it's an equation, cut it in half. And then we're trying to isolate the variable. Our variable's right here. So I'm going to do the opposite, the inverse. I can't multiply times 9, so I have to do the opposite, which is dividing by 9. I'm going to do that on both sides. Cancel these out. 27 divided by 9 is 3, so H ends up being 3. And then remember, we want to measure this in feet, just regular feet, because it's just a plain old height. The last problem is asking us to find the area of the shaded region. Okay, so notice this is a rectangle, and inside it is a parallelogram. The outside of the parallelogram is shaded, but not the inside. So what they've done is they've taken a large rectangle and they cut out the middle part of it. So I need to find both areas, but what I'm going to do is find the area of the large one and then take away the area of the small one. So I'm going to find both areas and then subtract. So let's try that. The area of the rectangle, base times height, I need to multiply 31 times 18. So 8 times 1 is 8, 8 times 3 is 24. Start with a 0, 1 times 1 and 1 times 3. When you add these up, you get 558. I'm going to do the same thing with the smaller parallelogram. You need to multiply 6 times 13. So 13 times 6, 18, carry 1, 78. And again, because I'm taking away this area, I'm going to end up subtracting the two areas. So 558 minus 78. When I subtract, 8 minus 8 is 0. I need to borrow. 15 minus 7 is 8. And then I'm going to bring down the 4. So the total area of just the shaded part is 480. And this is going to be measured in square millimeters. All right, so just to sum it up, the area is the number of square units it takes to cover a space. The area for a parallelogram, the formula is going to be base times height. And that's going to include your rectangles, your squares, and any quadrilateral that has parallel sides. All right, so thanks. Have a good evening.